All right. Let's do this. JavaScript Quake in just 13 kilobytes. Let's go. Q1 K3 making of. This was my third time participating in the JS13 Games contest. I won in 2018 with Underrun and utterly failed to deliver any compelling gameplay in 2019. Entry Void Call. This year's theme was space. I chose to completely ignore it and instead decided to pay tribute to one of my all-time favorites game on its 25th birthday. This is great. This is how you do it. You know, nothing is better than given a set of rules and being like, yeah, forget your rules. Here's what I'm going to do instead. The original Quake from 1996. Look at that. That looks pretty good. Dude, look at that. Look how blurry it already gets. Damn, this is some good looking stuff. Look at that guy. This is like, dude, this is... Did you see that? That's like my level of graphics on my little Doom game I made. This is looking good. In homage to Quake and 13 kilobytes of JavaScript. I grew up with the Quake series. See, I grew up with the Doom one. I feel like I must be a little bit older than this guy. Like so many others, the openness of Quake engine lured me into the tech world. In the early 2000s, I created maps for Quake 3 and later tinkered with the source. See, I did Unreal Tournament. Unreal came with the editor. And that was so cool. I never understood it. I spent hours playing with it and never quite understood it. I played so much Unreal. Holy cow. Unreal, the original, by the way. We're talking about the OG. Did you know that there was a gun in there called the quad cannon? Or the quad rifle? Not UT. Unreal. Like the original Unreal. Did you ever... Unreal. Just the Unreal, the game. The very first one. Yeah, dude, I spent so much time in this video game. Yeah, this was a good one. There was a weapon in here called it was super hard, by the way, too. This was like a super hard game, but there was a weapon in here called it was like the quad cannon, and it was like not fully developed. When you put it on, it like cover your screen and all that. You could get into all these things. Oh, dude, it was super cool. It was super cool. Absolutely loved it. Anyway, sorry. One of the first things I did with my Oculus Rift C1 arrived was porting Quake to it. The original Quake, in particular, has aged tremendously well. It is still an exceptionally beautiful game, kept alive by ever-improving engine like Quake Spasm, and ambitious mods like Arcane Dimensions and Alkaline. Capturing the essence of Quake in just 13 kilobytes with code, texture, sound, music, and weapons, enemies, and maps was both challenging and a whole lot of fun. This article details some of the techniques that made it possible. You may follow along with the source code. Cool. Oh, this is actually really cool. Okay. Q1K3 has 31 different textures stored as PNGs. They clock in at about 150 KB. So, simply including the textures as an image file was out of the question. Yep. Okay, we're already in some problems. Okay. We're already in some problems, boys. We're way over 13K. I initially tinkered with a simple DSL that allowed me to create canvas elements on the fly. To my surprise, this produced quite convincing results with just a bit of random noise and some embossed rectangles. Okay, let's check out this DSL for a quick second. How ugly we talking? What are we talking here? How disgusting is this one? I finally started my work on the JS13K entry, and this time I'm generating all the textures instead of relying on a ping file. Oh, interesting. Yeah, it has like grunge. Grunge, noise, create. Oh, interesting. Grass, sky, just as a color. Grass as a color, grunge it up a little bit. Dark, grunge it up a little bit. Put a little bit of noise on that water, then put some more noise on it, then create that. I like that he has underscore methods. That's my personal favorite in this situation going on right here, is the underscores. Okay. By the way, this looks good. Look at that grass. That looks good. Look at that water. That looks really good. Look at that underscore noise create. Maybe you should have just called it noise. Just throwing it out there. Maybe if you're going to use all of these, maybe just make them public. You know what I mean? Maybe just make them public. You know. This is super cool though. This is highly respectable. Highly respectable right there. I initially tinkered. Okay, we already did that. Let's see. To be able to compress this code even further and had some immediate visual feedback, I decided to build an editor for these textures. Knowing how to build tools. That's this is a lot of the times why I push you guys that building tools for the things that you find inconvenient are so useful, because this is the most obvious example of just super useful tools. Learn how to build tools. You will often find that the more you build tools, the faster you are at doing things. Instead of the above code, this produced a raw array of all values. You can pass the array of texture definitions to the T function to receive an array of canvas elements. Let's go. Look at that. One important addition to this editor was the ability to draw one texture onto another or or even onto itself. I also added a function to draw text. All in all, this editor and library supports only 5 different functions: embossed rectangle, embossed grid, noise, text, draw previous texture. This was enough to create the final texture set for Q1K3. The texture creation library and the definitions for all 31 textures clocking at about 1.3 KB zipped, way better than the 150K. Those look so good, and look at that, that's 9-inch nails. Let's go. We got 9-inch nails right here. Wow. Like, this one looks incredible. Damn, this looks great. Oh, this one must be, okay, so when he said he could draw previous texture, he probably took this one and mapped it onto this one, because this is like a 1-for-1. That is so good looking. Maps. I wanted to include at least the famous E1M1 level, episode 1 M1, map 1 from Quake. Generating levels dynamically is not very difficult for 3D games, but also wouldn't have gotten me to this goal. This meant the real map data had to be stored somewhere. Reducing all geometry to axis-aligned bounding blocks proved very efficient. Yeah, AABBs, baby. Everybody loves a good AABB. You know what I'm talking about? Granted, the missing slopes and absent details makes the game look more like Minecraft than the original Quake, but it was an absolute necessary sacrifice. Using only axis-aligned blocks not only reduced the data needed, but also made collision detection very straightforward. Yeah, because then, yes. Because I think even I can do the math. I can do most of the math, at least, on this kind of stuff. Oh, man. Somehow, my YouTube video started playing, and this is what I'm getting. There we go. All right, Flip, probably don't want to, I'm just throwing it out there, probably don't want to keep that in, just in case you're wondering. I don't know, Flip. Flip, it's under your discretion, but do realize that you get paid from this YouTube channel. Okay. But like looking at this stuff, oh man, I'm getting all horned up to take my little Go engine, and now maybe we want to do Quake. Maybe we want to make Quake. Maybe we want after tower defense, maybe we want to look at Quake and see if we can take Quake and make it so that everybody can play, but this time I want to do it. I want to do it via SSH. I think that'd be a lot of fun, that if you joined via SSH, you got to see the game and you got to use the controls. You got to WASD on your keyboard, and you just WASD'd and ran around. And so then it would take, like, say there's 1,000 of you all playing at the same time. It would take the average aggregate input as what the Quake guy should do. Could we do it? And then you know what we could do next? We could take each image and see if ChatGPT 4.0 could beat level 1. I think it could. You might just do Telnet instead of SSH, just because the CPU overhead of SSH. Yeah, we could. I may just make my own. I mean, the reality is I'll probably just make my own little CLI tool that you just launch, and it just colors the screen. Just uses ANSI coloring, right? And that way I can do my own. Like, because remember, we've hand rolled some compression, and this would be a really good reason for me to do the RLE and Huffman encoding quad trees. This would be a really great reason for me to do that, and then increase the resolution so it like looks pretty good, and increase the color size. I've been wanting to do it anyways. You know what I mean? Anyway, sorry. Dude, I can't help it. I want to be a game developer, but I don't want to be a game developer. You know what I mean? It's like I can't help it. What is it? Does every last person here suffer from that problem? Dude, we need to make quad trees happen. Dude, the quad tree idea is so good. Okay, hold on. Before we talk about it, let me tell you how good this quad tree idea was. Okay, so I represented the 2D canvas as a single buffer. And what I would do is that since every frame in its raw format is the same rows by column, right? It's always the same rows by column. What I would do is I'd create I called it a virtual box, that would actually go through here and create each one of the like quad tree rectangles throughout the whole code. And it would be stored in offsets. And so all I had to do was when a new frame got in, I just pointed the quad tree to the next frame. And so that way you never have to like regenerate a quad tree, because once you already know the rows and columns, and I already have the raw image data coming down, or the raw ASCII data coming down. So all I have to do is I just have to update it, and now it changes. Okay, you don't get it? Here, let me say it this way. So here's your screen. A quad tree, you just split into 4. Hence the reason why it's called a quad tree. And then you recursively do it again. Well, if you think about it, This rectangle right here, if it comes to a fixed sized raw data image every single time, you only need to store the offset. Let's say the offset on this one, of course, is going to be x prime, y prime, with a width of with the width of, we'll call it d3x, a depth of 3x, and a depth of 3y. Then what I can do right here is that all I need to do is just have a reference to the buffer, and I'm able to go, okay, well, that means I actually exist, right here in the buffer, right here in the buffer, right here in the buffer, right here in the buffer. If I had 4 rows, right, because that'd be 4 rows and then however many columns. Let's say this is 10 wide. That'd be a 4 by 10, right? That'd be a 4 by 10 rectangle in there. How cool is that, right? And so that means all I have to do is update the buffer that I'm pointing at, so I add pretty much no overhead of ever recalculating anything, and boom. What's the benefit to this complexity? It's really, really simple. I'll show you the benefit of this complexity, dude. We're way off. We are way off topic right now, but we're going to go with it, okay? I'm going to run do ASCII one more time. Dang it. It fell apart. But you get the idea. See, as this thing started to go down, you can imagine that a lot of the stuff up here isn't changing from frame to frame. So by not changing from frame to frame, I can rectangle this thing out and say, okay, unchanged. Only this area right here is the thing that changed, right? So we can actually capture the surface in which is changed, which is that little thing right there, and then the rest of the rectangles haven't changed at all. It's dirty rectangles, right? It's your classic dirty rectangles, right? Like, it's so fun. Dude, I don't know why I love this stuff. I just think it's so great. I just think it's so much fun to do this kind of stuff. And I wish I loved doing things like just building React CRUD apps and I could just work easily for a job. And then that's that. But I just suffer. I suffer with curiosity complex syndrome. Ardent Cobra, thank you for that tier 2, by the way. Thank you, Ardent. You just made it into this YouTube video. All right, let's keep on going. All right, Trench Broom saves the level in the .map format. It's the de facto standard for all Quake engine games around the time. A .map file contains a list of brushes, where each brush is a convex object. However, the brush geometry is not defined by the position of each corner, but rather by a list of planes that stretch to infinity. Each plane subdivides a conceptual infinitely large space into an inside and outside half. Classic just subdividing infinite planes until we have a convex object. With 4 or more shape subdivisions, you end up with the remainder of all that's inside a brush. This also explains why all brushes need to be convex by definition. Yep, it does. That makes sense. Historically, this format of a map file was chosen to make previous computations for Quake binary space partitioning (BSP) compiler easier. The Quake engine itself also uses these infinitely large planes for collision detection. Testing if a point is inside of a brush is very cheap when you only have to test if this point is on the right side, the inside of all planes. For my purpose, this .map format was quite difficult to work with. Luckily, I already built a .map parser and loader in C for another side project. I quickly adapted the map loader to take the computed corner points of each brush and produce a list of blocks. All blocks of Q1, K3 levels are axis aligned. This means I only need to store the position and the size of each block. Initially, my level format looked like this. Okay, beautiful. Nice little struct with some structs on the inside. Ain't nothing like some structs with some structs. Yo, dog, I heard you like structs, so I got some structs with your structs. This is some advanced seeing, by the way. This is some advanced seeing going on right now. Video encoding people are the coolest. I've been trying to get into video encoding. I really have. In fact, that might be one of the, you know how I tell you guys to like pick your specialty? This is kind of where I've been going. It's something I really like. And so maybe that's what I'm going to go and get my master's in. When I was young, getting my first master's, and I was doing it in ML, this was during the AI winter. I really liked it. I just wasn't, it just wasn't like it wasn't a passion project. Audio is cooler. Well, I mean, audio and video. If you're gonna go and study those, you're gonna be studying both of them, right? You're not gonna just do video. You're probably gonna do audio as well. Taking on FFmpeg head on. I don't want to take on first off FFmpeg Twitter account. If you've never taken a moment to just listen to it, it's fantastic. Okay. They are the craziest account of all time. I mean, they're freaking talking about Tolstoy just recently. In the last 3 to 4 years, half of computer science research was taken over by ML. Yeah. Towards the end of the project, I had to revisit the block format to shave some more bytes. In the final version of the game, each block takes only 6 bytes for the position and size. Shit. Okay, so 6 bytes for the position and size. So assuming that means there's four variables, right? X, Y, width, height, right? You need 4, right? So that means if we have 6 bytes, that means he's probably doing what? Doing 12 bits? Or what is that? That's 496? 496? So you have a maximum value of some value between what? Negative 240, what is that? Is that 248? Negative 248 to positive 247. So that's as big as a block can get. I guess that makes sense. You probably don't, or at least the positioning. Your positioning can be that. I guess, they could also say the blocks aren't that wide. So maybe the blocks never got all that wide. I never remember if the negative is, I never remember where the 248, where this is at. Is it 248 as the maximum or negative 248 as the negative? I never remember which side gets affected by the 0. Is it the positive or the negative? Anyways, or I guess you could do 2 bytes for X, Y, assuming that the levels are large, and then 1 byte for width and height, just assuming that you never have a box that's that big. But these are all 2D boxes, and he's doing 3D boxes. So wouldn't you have in the final version, each block takes only 6 bytes for the position and size. So you'd actually have a third variable. I forgot you'd have a third variable. What would you do with the Z? Oh, I guess length. Okay, so he is only doing 1 byte. He's doing only 1 byte for each one, right? He's only doing 1 byte. Dude, I totally did this in 2D. He'd be doing this in 3D, so he would actually have X, Y, Z, right? Huh. Okay. The list of blocks is sorted by array texture index and interleaved with texture change sentinel. Why do you even need to store it for 6 bytes? Because in JavaScript, you can't store it for 6 bytes. Like, that's not even an option, right? You're going to have either an array of values or you're going to have that. So the representation of every hard-coded block is going to be based on a string size. It's not going to really be based on the binary store size, right? Curious. I must be misunderstanding something. The list of blocks is sorted by the texture index and interleaved with the texture change sentinel that denotes the texture index for all the blocks in the file. This saves around 300 bytes for each of the 2 levels. I guess, yeah, you could base 64 it, maybe. I also experimented with just using 6 or 7 bits for each value, bringing down the block size to 5 bytes. As I painfully figured out, this is horrible for zip compression, which examines the file on a byte by byte level. This, however, leads me to squeeze another 50 bytes or so by just sorting the block size, which aids the zip compression. Nice. Nothing like storing data to make zip better. Okay, I didn't realize are you zipping it? How are you unzipping it? Okay, now I have so many questions. The entities stored in the file just have a type ID, a position or 2 extra bytes for data. This extra data is used for lights to store the light color and brightness, and by enemies to indicate if they start idle or patrolling and which direction they're facing. Okay. You cannot say entities without saying titties. It's true. In the end, I managed to cram most of the E1M1 Sans secrets and part of E1M3 with a lot of freestyling into the game. In a total, 2 levels consist of 563 blocks and 188 entities, a total of 4.5 kilobytes uncompressed or 3.2 zipped. How did you unzip, though? Because that's my question, it's the unzipping that I'm more curious about. This geometry for all game object, weapons, enemies, and various pickups, and some map decorations follow a similar approach as for my 2009 entry void call. Just a list of vertex indices followed by vertex positions. Animated models have a list of indices once and the vertex positions for each frame. For void call, I tried hard to maximize or minimize the byte size of the models. I only used 5 bits for each vertex position. This meant that each coordinate is interleaved in 2 bytes. As I noted earlier with level files, this actually trips up zip compression because each byte almost looks like random noise. Yep, that makes sense. And so for Q1, K3, each index and vertex coordinate is stored in an individual byte. This allows for better zip compression and saved a few hundred bytes in the final build. I carefully removed all the faces from each model, which will not be seen in the game, to save a few bytes here and there. This means the box model has no underside, and in the most extreme case, the Quake logo on the title screen has most of the sides removed. Nice. let's see, there's only 3 different animated models in the game. Basic humanoid with 6 animation frames, a dog with just 2 frames, and a torch model. I only use, let's see, only used in the second level with 3 frames. The humanoid model is reused for most enemy types by stretching and shrinking the X, Y, Z, and applying different textures. E.g., the ogre is transformed to be a bit shorter and wider than the enforcer. Let's go. This is clever. A cylinder model is used for exploding barrels, the projectile fire by the nail gun and plasma gun from the enforcer, the grenades, and even the grenade launcher and the shotgun itself. A simple box model is stretched to become the health and ammunition pickups and the doors. The humanoid model is divided up into individual pieces to become gibs when killing enemies. I'll never be this smart, damn. I think you will be. I honestly think you will be. Textures for the model are dynamically created with TTT and just projected onto the model from the front. This produced some ugly artifacts on top of the barrels and sides of the ammunition boxes because the texture is infinitely stretched or squashed, but it is hardly noticeable in the game. All models combined take up to 1.6 kilobytes of uncompressed or 1.1 zipped. I'm still curious about the zipped business because how do you unzip it in the browser, right? Isn't the whole point is that we're unzipped in the browser? Doesn't this make a whole problem because then you have to use, well, wouldn't you have to use a library to unzip it, which is probably more than a few K? Browser unzips on every request. Oh, is part of, no, I don't get it. I think he means I think he means gzip, which browsers handle. Yeah, but with JavaScript, you don't get binary storage. You just get UTF-16 storage technically. There's a compression stream that can unzip. Oh, interesting. Okay, I didn't know about compression stream. Okay, well, this is newly available. This is 2 years. This is 2 years before this is 2 years after he created it. Okay, cool. I didn't know about this. I did not know about this. This is cool. All right, typed arrays. You do get typed arrays, but again, typed arrays are binary in JavaScript. They're not binary in the JavaScript code. So if you were to effectively do a binary array, you would have something that looks like, new array buffer, right? And then you'd have to have a new view of some sort. Or I guess you could do a new uint8 array. That'd probably be good enough, a new int8 array. And then you have to specify each one of the uint8s. Oh, it's part of the competition. It has to be submitted. It has to be 13K zipped. Okay. So the competition houses your JavaScript result, and it's in a zip file. And if the zip is 13K or less, then you're a part of it. Okay. Sorry, my bad. Okay, that makes way more sense. Now I'm tracking now. I'm tracking betterish. I looked into the excellent ZZFX library for the sounds and ZZFXM for music. The ZZFXM tracker to create music is a particularly nice piece of software. ZZFX works great for 8-bit-ish effects, but I found it very hard to create anything that doesn't sound like a NES. Andy Losh, who did the music for Q1K3, faced similar challenges. So I ultimately decided to go back to the trusty Sonatent X that I've been using for previous years. The version used in Q1K3 has been heavily modified to make it smaller while retaining all the same features of the original. In the previous years, I modified the library to generate lookup tables at startup for all the different oscillators, sin, square, sawtooth, triangle, instead of computing those on the fly. Classic sin square or sine, square, sawtooth, triangle. Classic. That's crazy. Getting the current value for the oscillator is then a simple lookup. The speeds of the music generation a lot, to the point where there's only 100 ms delay from clicking on the start screen to being the game with the music playing. That's pretty cool. That's super cool. Yeah, that is crazy generating all of this. All right, that's wild. This year, I also hacked the Sonnet X tracker to store all the music in flat arrays instead of a JSON object. This further reduced the size needed for all music. Yeah, oh, absolutely. There we go. Now we're talking. Just, yeah, drop all of that. Drop all of this crap, because that's crazy to do it any other way. Like for my previous games, the music for Q1, I mean, he could have used something like flat buffers. Real talk, you could have done the same idea as flat buffers, is just have, like, your next character right here, instead of being this triple-sized array, you could have just had how many of these chunks are here, right? One, you could have had, like, a count or something. I think that might have been more efficient, because then you don't have to have all these brackets everywhere, but who knows? Anyways, very exciting. I love that kind of golfing. Code golfing is so much fun. Like, for all my previous games, the music for Q1 K3 was compressed by my good friend Andy Losh. For Q1 K3 space was even tighter than for the past JS13 games. He still ended up with a brilliantly moody, minimalist ambient track that compressed nicely. The minimalism fits the game perfectly. After all, the original Quake soundtrack from Nine Inch Nails that we're both big fans of has a similar theme going on, and I'm really happy with the results. Okay, so when I jokingly said Nine Inch Nails, it literally, the original, or where did the Nine Inch Nails go? Nine Inch Nails, I didn't realize Nine Inch Nails made the soundtrack. Well, let's go. Okay. In contrast, the sound effects were difficult to produce with limited possibilities. In my opinion, they don't live up to the game. With my very limited understanding of audio filters and synthesizers, I have no idea how to improve the situation. Maybe it's just not possible or extremely complex to create good sound effects out of thin air. What worked nicely, though, is very simplistic spatial audio model used in Q1K3. Whenever an entity wants to play a sound effect, the distance and angle to the camera is computed, and the volume and stereo panning is changed accordingly. I'm not a music engineer. Don't even get it. Don't even understand it. Sure, and yes, and probably, and math dots sine. So yeah, probably correct. I would have probably used cosine. Okay, I'm more of a cosine bro than a sine bro, so maybe, my girl's all about the tangent, It's only about 10 lines of code, mostly just connecting different web audio objects to each other, but greatly helps when you want to figure out who's shooting at you. Stepping back a bit, it's quite funny to me how exhaustive the web audio API is, yet everyone generates samples directly in JavaScript instead of connecting the dots on a designed by consortium audio graph. At this point, it seems to be a tradition of the W3C to implement all the wrong abstractions. Speaking of that, when I did Doom, when we did 1,000 people playing Doom, which, by the way, I think that video should be out here this week. It should be out very, very soon. I'm not sure exactly. But the W3C implemented the WebSocket interface. And if you don't know, WebSocket API is an advanced technology. Advanced technology. If you don't know this, when you specify that you are a binary message, what you get back out is a blob data storage object. The blob data storage object here, let me just show you this for a second, because this might be the most upsetting web API I have ever seen in my entire lifetime. I don't think I've ever been this angry, ever, for any reason, ever. Okay? WebSocket, WS index. So right here, when you get a message, and it happens to be a blob storage, so this is a blob storage right here, you get a blob storage. And a blob storage, the array buffer is a promise. Yes, so this is something that I've learned later. There's apparently a binary type property that when you use this binary type, it actually prevents the array buffer from being behind a promise. I did not know about this. Now I do know about this. So you don't want to use the word blob in a string. You want to use the term array buffer. So I actually did not know that this even existed, okay? I didn't know. I just didn't know. This was a thing. Apparently this was a thing. Anyways, for those that didn't know that this was a thing, for those that didn't set some random property on your WebSocket from blob to array buffer, skill issues. Yeah, real skill issues. New to me. It's new to a lot of people because it's crazy. This one right here, this one returning a promise. Even though WebSockets, remember, WebSockets are over TCP. TCP is guaranteed in-order data. Guaranteed in-order data. WebSockets is framing on top of guaranteed in-order data. Due to it being a promise, I would get frames out of order. I even put a sequence number in there to prove if this was happening, and it was happening. I was getting frames out of order. Dude, TCP guarantees you that when you send ABC, you get ABC in order. Crazy. Add sequence output, so rad. Yeah, dude, I literally sequenced my data. I literally just finally got frustrated and said, you know what? Forget about it. We're going to have a sequence in here, okay? We're just going to have a sequence. I have to have a sequence because I have to know what's wrong. I have to know why this is happening because it makes no sense because I couldn't understand it. I finally just erased it and made some things, but I even had this one, a debug assert that has a 1-byte thing that I was able to predict when it was happening. Dude, that was so hard because the problem was one of my encodings was XOR RLE, and XOR RLE depends on the previous frame. So if you got something out of order, the whole screen would start getting effed up. Just set sequential buffer on true. Yeah, classic, because that makes sense for a TCP protocol to set sequential buffer to true. You only learn these things later on. I'm dumb, okay? Technically, TCP cell can write it out of order. It's just reassemble. Yeah, I understand that TCP itself can be received out of order, but that's the point of TCP, is TCP re-puts it back in order for you and hands you one blob at a time. All of this because of a single property? Yeah, didn't know about the single property. Anyways, who would have ever thought that your WebSocket needed a property to say, hey, keep you in order? Like that, I literally wrote the WebSocket protocol that is used on every single television for Netflix. I hand rolled the WebSocket protocol. I know it pretty well. I've never heard of somebody being like, by the way, it could go out of order. Just in case you didn't know this, it goes out of order. That's a flex. Yeah, that is a flex. Because dude, toxic binary type scalinity. Yeah, it is. I didn't know this. Yeah, it just pisses me off. It's just, why is that code? Why did you write that code to begin with? That's what I want to know. Why did you write all this extra shitty code for something that doesn't even exist? Right? There is no world that exists that this happens. Why would I hand you the frame header before you get the data? You can't even do anything with it. So stupid. It's so stupid. Maybe they were planning. No, they weren't planning, okay? This is the problem about JavaScript in general, is that every last person thinks they're some highfalutin crazy language designer that's going to come in with the greatest interface ever instead of just doing what is obvious and straightforward. Like, hey, maybe we don't need to be clever here. Maybe we take the WebSocket, and when it gives you a frame, you collect the frame. When the data's done, you hand it to the next person. Just a little callback. Like, hey, here's your string. Hey, here's your binary. Hey, string, binary. String, binary. I don't know, because maybe that's how it works. Like, you had to go out of your way and write hundreds of lines of SIPP to actually make it out of order. Like, somebody had to make an interface that's even possible to be out of order. Oh, I'm so stressed out all of a sudden. You guys just made me stressed out. All the assets with the 3.2 kilobytes of level data, 1.1 kilobyte of model data, 1.3 for textures, including the texture lib, 1.5 kilobytes for sound and music, including the audio lib, sum up to a total of 7.1 KB within the zip. This leaves a generous 5.9 for all the remaining code. For the remaining code, I had to handle unpacking map files, unpacking model files, input physics, collision detection, rendering, model animations, enemy AI, and gameplay logic. Let's go. The basic architecture for the game resolves around an array of entities. Each entity type, e.g. the player ammo pickup enemies, is a subclass of the main entity. They all share... Oh my goodness, did he just say OOP? Did we just get OOP mentioned? Sir, this is JavaScript. You better be functional. If this is not functional, then you know what? This sounds like OOP. They all share the same physics, calculations, collision detection, and a bit of game logic to receive damage and die. What was in that egg bagel? Testosterone. For each frame, the game iterates through an array, updates the physics for each entity, and draws it out. There's almost no game logic going on outside the entity class. Everything in Q1, K3 is an entity, even the tiniest particle. For all my previous games, I tried hard to avoid 3D and vector math wherever possible. I told myself that I did this to avoid the added code, but the real reason was more that I suck at math. Yes, I suck too. Even as someone who's done a lot of math, I used to be able to hand roll quaternion rotations. I could do it all. I built one of my graduate projects was a camera that went around things, and you could morph a mesh however you wanted in OpenGL, and it all had to be done with my own built libraries. No help other than GL rendering. And so I rendered a thing. I rendered everything, and I could move it all over the place, and I could quaternion every last part of it. It was a lot of fun. I didn't know about Euler angles, okay? There was no one was oiling me up, okay? I do want to get back into, I do want to get back into them quaternions again. That was so much fun. I want to get back. Dude, see, my game programmer side is slowly just coming back, and I can't help it. It's like the moment I have free time, I'm just like, I'm going to build a game. You know what I'm going to do? You know what I'm going to do? I was just thinking yesterday that I don't get punched in the dick often enough. So I thought, hey, you know what I'm going to do? I'm going to make my own game. And then I'm also going to do my first game in Zig. Because you know why? Because I was thinking that, again, since I haven't been punched in the dick lately, I could get double punched, one for each dick, and just get clapped. I have this exact thought process every 2 months. I know, it's the worst. Each dick. All my previous games, I tried hard to avoid it. Yes, I do too. Whenever I needed some 3D math, I used Brandon Jones' excellent GL Matrix library. It's the de facto reference implementation for vector and matrix math. You know, to this day, I still say ISROT in my head. ISROT. Any game devs out there know what I'm talking about? Do we got any game devs with ISROT? ISROT. I bet you there's going to be some people that are going to tell you exactly what this is. Here we go. I'm rolling on the floor here. I'm sorry. I'm getting really into this. Anyone? ISROT? Come on. Really? Come on. It's the order of the matrices. Yeah, X and A. Let's fucking go. You know it. This is the order of the matrices that you have to multiply together. You do your identity matrix multiplied by your scale matrix, multiplied by your rotation matrix, multiplied by your orbit rotation, multiplied by your translation matrix, and this gave you your position in the world. Isrod versus Palpatine. Okay, come on, guys. Way too dang. Come on, you didn't do this? You didn't hand roll your own matrix Guys, virtually no one does their own 3D code anymore. 99%. Yeah, I know no one does 3D code because it sucks. Okay, it's the worst. Everything uses big engines now. Yeah, that's probably true. I wonder if you'd be into graphics programming. Yeah, definitely recommend checking Esarolo's channel for it. Okay. Yeah, I maybe I am. You're just old. Is this what old people look like? Is this what old people look like? Is the fact that I just did all this? By the time we did X and A in school, my group said, fuck this, let's use Unity. Oh my goodness. I'm old. Oh my goodness. I can't believe it. GL matrix goal is to be as fast as possible. This means never allocate any objects if you don't explicitly tell it to do so. It also means that it's a bit cumbersome to work with. You have to pass an out object. Yeah, I love that. Oh, it's so much fun to use those APIs other than, of course, said dick punching. I hate JavaScript. Welcome to the club, Dunderwalk. An object to almost all the functions instead of receiving the results of the function's return value. So I chose to ignore the efficiency gains of the GL matrix architecture, instead implemented a tiny vector math library that is nicely composable. The vec3 star functions create and return plain JS objects. This introduced a lot of work for the garbage collector, but in turn allowed me to write code like this. Let's go. Player acceleration, vector3 mulf. Give me that multiplied by a float. Is that what it is? Yeah. Rotate Y. Let's go. Vector. Okay, we got a vector. We're gonna hit him with the yaw. Damn, we got yaws in here, bro. We're yawing. We're yaw pitching and rolling. I love mulfs, dude. I love mulfs. Okay, mulfs. Yaws queen. Having all these vectors functions readily available instead of fiddling with math sign and accessing the vector components directly was a good idea after all. Collision detection. Ooh, this is gonna be fun. AABBs. Collision detection can be a hairy thing. Dude, I used to buy like college level geometry books trying to understand how do you I could not figure out how do you make a non-infinite plane and a sphere know when you're colliding. Like, this was really hard for me. You know, these things can be really hard because you got to compute the normal vector shit like that, because it's like, it's like this. You got to compute the distance properly. Dude, it was really hard. It was really hard because you had to calculate out this spot right here. Like, how did you get this? It's all about the radius, man. Yeah, but with the plane, depending on how you say your plane, you may not know, you have to calculate out what this position is. And then from that position, you got to take it, and then you can calculate out the distance between. Dude, it's really hard. Okay, it was really hard. Those are by days. Okay, which game are you playing? Hey, calm down, Lithium. Let's see. Okay, what happens when there is a collision? Can get all kinds of wonky. In Q1K3A made my life a lot easier. Only dealing with axis-aligned bounding boxes. Still, there's a bit of complexity involved in dealing with collisions against a static level geometry and also against dynamic objects. In both cases, the same collision responses is employed. Did he do an octree? Did we octree it? And when the level is loaded, the uint8 array for the 128, 128, 128 grid elements, that's why we did 1 byte. Remember when we were talking about this earlier? Yeah, when we talked about this, it's 6 bytes with XYZ, width, height, length, maybe girth somewhere in there. I'm not really sure. It's because it's 128 by 128. Okay, there we go. That's only 2 to the 7, boys. You don't even need 8. That's 2 to the 7. Since I only needed to know which of the grid cells was occupied, I used a bitmap where each bit corresponded to one cell. So instead of this thing, bytes on the uint8 array, I needed only this many bytes. All right, let's go. Looking up 1 bit in this array is then just this. Okay, cool. Collision map index. Nice. Element. I like it. More concisely, hell yeah. To check if an entity collides with one or more cells in the bitmap, the entity's whole box is checked. Let's go. This is the ugliest code I've ever seen in my life. Let's go. Ain't nothing like it. This map block add box check is done for each of the X, Y, Z dimensions. On top of that, these 3 checks might be done in a loop for fast-moving entities. Checking for each dimension individually ensures that we can slide along the floor and walls. We only need to stop moving in a direction in which we hit something. Nice. Look at that. Divided movement into 16 unit steps. Let's go. Look at all this milfing. We're mulfing. Dude, we're doing so many mulfs and collides and adds and clones. There's a bit more going on in the final code, including a check. I'm not going to go through this because obviously I'm not going to understand it. Fugliness is next to godliness. It really is. It really is. Dude, so many moves. Including a check for stepping up the stairs. By the way, after seeing this code, it does make me feel like, you know what? Our upcoming little Zig game loop that we're about to do, and just the ugliness of the input. Look at this. Look at that interface. It's so beautiful. Doing this next one, oh man, I'm completely okay. You know what? Sometimes I try to make things into this nice idea, and I realize sometimes you just gotta raw dog it. You just gotta raw dog it to have 3 nested for loops, okay? Sometimes it's okay to have 3 nested for loops. Man, I love frogs. Dude, MILFs, I love frogs too. This is all terribly inefficient. It doesn't matter. CPUs are fast. I think the better phrase to say is that your set of movable and unmovable objects was low, not that CPUs were fast. Man, I love fishing. MILFs. The rendering for Q1K3 is quite simplistic. All entities are rendered for each frame. There is no checks if an entity is outside the view frustum, or if it's occluded by some level geometry. Hell no. Likewise, all level geometry is rendered for each frame. We get a lot of overdraw this way, but since polygon count is quite low, it still works. GPUs are fast. Let's go. You realize this phrase, CPUs are fast, is the reason why we have React? Okay, we'll keep on going. Light sources were one thing I needed to address, though. The game has a hard limit of 32 light sources that can be rendered for a frame. This includes all lights scattered around the level, as well as dynamically created lights when shooting a weapon or when something explodes. During one frame, all entities submit their lights to render. The render determines the distance to the lights to the camera and fades it out at a certain distance. If it's too far away, it's not rendered at all. Okay, yeah. Let's go. This is looking good. I like it. Classic code. Not even going to try to digest this because it's not even worth it for me to think about. There's only one shader program shared by the level geometry and models. The vertex shader takes care of the current camera position and view angles. It also mixes the animation frames and models. Okay. The fragment shader calculates the lighting from all light sources and applies some cheesy gamma correction and reduces the number of colors for extra dirty look. All geometry for the 2 levels and all the models and their animation frames are uploaded to a GPU buffer on load time. The render then just needs to issue draw calls with offsets to this buffer. There's 1 draw call per model and 1 per level block. This sounds excessive, but it is not a big problem. The level data is already sorted by texture index, so the render doesn't need to rebind textures all too much. Similarly, the static geometry, the vertex attributes, or attribute pointers all stay the same. The render just needs to change those for the animated models. Dang, I don't really understand this part, honestly. You know, I'm just a lowly ASCII game producer. I'm just a lowly ASCII game producer, not some real graphics hero. Start from here. I have a friend who built a radar system visualization in Unity for the DoD. Well, shit as well, I can imagine it. All right, minification. The minified source Q1K3 is about 71 KB. The first step to get the size down is PHP script that replaces WebGL constants with their actual numerical values. What? Out of all things to use, a PHP script? Our boy woke up and chose violence. Lambo Lang, let's go. Okay, it also shortens WebGL function names as explained in the underrun making up. Okay, just to make it easier maybe, because they must be properties. Minifying the source with Uglify.js brings it down to 26 KB. Still a lot, but JS 13K's size limit only is concerned with the size of the final zip file containing all the assets for the code jam. Zipping the minified source shrinks it to 10 KB, but I need more space for the maps. Yep. While zip compression helps a bit for the data files, the zip with the source and data still clocks it at 14.2 KB. Where's he going to get that extra K from? Where's the K come from? Grandpa Mitch? Grandpa Mitch? Where's it coming from, Grandpa Mitch? By the way, thank you, Grandpa Mitch, for that tier 3. You're right in the middle of this video. It's happening. Luckily, a few days after the start of JS 13K, Kang Seong-gun released a Road Roller, a JavaScript packer written in the spirit of an old-school UPX. Road Roller compresses your source code and appends its own decompression code. Loading the packed source code in the browser unpacks immediately and executes it. Hand Roller essentially provided me with an extra 1.2 KB totally free, without any need to change my source. Without a Q1, K3 would likely have ended up with only 1 level. Wow, hand-rolled really went down. Let's go, hand-rolled. That's cool. I've been wanting to actually do this as like a side project, which is to use Tree Sitter and look through your code for similar patterns and see if you can up-level those patterns into functions and like morph your code and do that. I think it'd be pretty neat. I think that'd be really fun to try out something like that idea. Pantalonians, how you doing? Hey, thank you, D Fizzy. I appreciate that. Coding Gatsy, thank you. 1 year at the startup, and Garen still doesn't know my name. It's coding at sea. No, it's coding Gatsy. And coding at the speed of light. Yish. Hey, thank you, Taco Bennett. Thank you for the 3-tier gifted subs. Appreciate that. Let's see. I truly loathe modern JavaScript with its ever-changing, extremely fast bundler of the week, be it Babel, Grunt, Gulp, Webpack, or whatever else is in its fashion. The funny part is I did start on Grunt. Before Grunt, I rolled my own using Google. Google what the hell is it called? Google something compiler. Google, what the hell is it called? Why can't I remember the Google compiler? What's the Google compiler? Closure. Dang it. The Google Closure compiler. Let's go. The Google Closure compiler. Thank you. The Bizil. Appreciate that. Man, and that was such a pain. And when Grunt came out, I thought it was a send from heaven. And then Gulp came out. I thought Grunt was cooler. Okay. And then I learned I did like Gulp a little bit better. Then Webpack came out, and I wanted to commit Sudoku. All right, so my build process is just a simple shell script. Because of that, I can assure you that everything still works tomorrow. I also made sure my game works when you just load uncompressed source code. This greatly simplifies debugging and makes seeing changes as easy as pressing F5. I still can't wrap my head around the idea of compiling JavaScript. Please get off my lawn. What an ending. What an ending. Let's go. Still can't understand the idea around compiling JavaScript. John Carmack, founder of id Software and lead programmer on Quake, liked my post on Q1K3. Let's go. Neil Graham extended a tiny texture Tumblr source to include his own Stacky library, SVG paths, and more. I found a possible bug in Chrome where typed arrays are neutered by the GC all while the game is running. I worked around this problem in the final release, still need to build a test case for it. Q1K3 made it to the front page of Hacker News, so did my 2018 entry Underrun, albeit shamelessly self-submitted. Q1K3 is apparently good enough to compete with other non-size restricted JS games. It's listed on many gaming sites. In general, riding the nostalgia wave seems to be a good way to get media attention. My 2015 reverse engineering of Wipeout produced a lot of buzz too, presumably the same size. Nice. That's because a bunch of millennials use the internet. Okay? Obviously, the internet is just millennials. That's why. Final thoughts. With each game I built, JS 13K, it became more and more evident the way to go is generating data in code instead of directly authoring it. For Underrun, all the texture and levels were directly authored in Photoshop, resulting in a tiny low-res game. For Void Call, I generated a game world with lots of Perlin noise and made it more organic. For Q1K3, I generated the textures. Naturally, I want to explore generating 3D models and animation. In this regard, another game for this year's JS 13K, Adventures of Captain Callisto, particularly impressed me with its clean and smooth 3D models. It is very cool aesthetics and very nice works around the size limitations. I still have to go through the full list of games this year, but some of my favorites are The Maze of Space Goblins, Two Ships Passing in the Night, Shadow of the Keening Star, and Galaxies. For the next time, I also want to go into sound generation a bit more. I wasn't really happy with how sound effects in Q1K3 turned out, so that's a field I need to learn more about. Just a whole field, the whole ass field. I'm going to learn about sound. GIMP, Excalidraw, yeah, that's right. Just become a GIMP master instead. All in all, Q1K3 was one of the most fun projects I ever worked on. The game is neither original nor very creative. It doesn't match all the contest themes, and I don't expect to win anything. But having a very clear goal and just figuring out how to get there is extremely rewarding. Agreed. Can't wait for next year's JS 13 contest, where I'll completely ignore this theme again and try to fit Super Mario 64 or another classic into 13KB. Dude, Super Mario 64 would be crazy. That would be crazy to try to fit that. Play it. Where's the link? Whoa, that's really good. Sorry, I'm using QWERTY. Dude, that was so good. I'm using QWERTY, so I don't even know how to move forward. Where's W? Dude, I can't even remember where W is. Oh, nice. Okay. Oh, gosh. Oh, gosh. It's not inverted. I can't do it. Oh, it's so sensitive. Oh, it's lagging. Let's go. I can't believe how good this looks. Like, this looks so good. I can't strafe. I can't strafe around this corner. Oh, it's... I died. Dude, this is... Okay, it's weird playing this way, okay? Shut up. Don't judge me. Oh. Oh, got him. Got him. Beautiful. Absolutely beautiful. The light looks really good in here. Like, look at how good this light looks. This is really good. The garbage collection. This is really good. Let's see what is the slowest part of his game, huh? I think that's going to be fun. Oh, boys, inverted. It's so over. It's so... Oh, gosh. Oh, gosh, I can't. Oh, yeah. We're so over. Oh, gosh. Whoa, hey, got him. Oh, I can't strafe. Oh. Oh, yeah, suck it. Can't strafe. Oh. Let's go. Let's go. Let's go. Oh, there's so many of these guys. Well, that must be that's the big boy, huh? Oh, dodge it, dodge it. All right, there we go. We ran all around. Oh, how do I get my mouse off here? There we go. All right. Let's see what we did. You died. I can't use a normal keyboard? Have you not seen my keyboard? It's Dvorak. It don't got no letters on it. All right, let's see what we got here. That looks slick for 13K. That's really good for 13K. What the hell was that? That's called... Oh, no. Come on. You can do this. All right, all right, all right, all right. So it looks like we have a lot of system time and a lot of script time. Come on. Let me select it. Let me select it. All right, we'll just try to click on it. What is clear? Clear takes up a lot of time. That must be one of the ones that we keep feeling, which is this clear function. Huh. Crazy. Dude, how come I can't select on these things? Can I search on things? How about, is it just GC? How do they do this? I think they call it garbage. Oh, zoom in. We're zooming. Yeah, look at that. Mostly, it's doing really good. Look at that. These little frames are doing really good. These frames are doing shockingly good. Look at that. You have an animation frame. You have your animation frame. You got some pre-paint. You got a commit. This is looking really good. And then where was that GC at? Dude, bro, let me see your GC. Oh, this is a GC? Are you saying this is where's the GC? Usually you have like a task that's just called GC. I'm confused why it doesn't say the word GC. Yo, keep my game out your mouth. Dude, look at how cool this is though. By the way, look at those stacks. Can anyone just look at these call stacks? So this, the call stacks right here. Do you guys notice something about these sweet call stacks? They're only like 5 deep. How does that make you feel, React? How does that make you feel? I don't. Well, I recorded a lot of data. I probably recorded too much data. I was having too much fun here, okay? I was having too much fun. What is clear? Is there a way to jump to it? Is there a way to jump to this? And not clean code. Clearly not clean code. What is this, like the Italian flag over here? I wonder what this does. Is there a way to like jump to it? That seems to be your biggest problem in there. This is cool. This is actually super cool. I'm surprised. I'm genuinely surprised at how well this ran. Like this ran really, really, really well for 63 milliseconds. It's also crazy how much time is just spent being idle. Look at this. Most of the time was spent being idle. In other words, most of the time it just wasn't done. Like all the lag and everything we experienced was just because of garbage creation, not because of anything, anything else. Bottom up. Give me those bottom ups, boy. So, total time. Give me your total time. I don't know what function call is. What is FT? Request animation frame for FT. Okay, it did a lot of stuff. FT looks like it did some stuff. It did a little bit of 4 vars. You know what I'm talking about? It did some 4 var S of HTs. You know what I mean? Thanks for playing the end. Thanks for playing the end. Thanks for playing Unicode character. It must be a smiley face. Very clear. Very clear. Very, very good. Here's clear. I guess clear only happened only 2 times, and that was only in the beginning. Or it was one midway through as well. Clear must be something else. Clear calls FT. What is clear? I don't know what clear is, because clear doesn't have a spot that I can go to. Anyways, whatever. This was super cool. This was super, super neat. That's when you died. Oh, is that when I died? Okay. Yeah, I guess that makes sense. I did die twice, right? Yeah, Quake Generation approves. The Quake Generation does approve. I approve. That was absolutely fantastic. What a great story. I love the idea of trying to build this kind of stuff. And the music was good. Those were some pretty good sound effects given how they were generated. Pretty dang good. You know what? That was awesome. The music was good. Very grungy. Super moody and grunge. Yeah, it was great. It was great. Good job. Good job. The name is Call Me Impresstogen. Okay? I'm impressed right now. Color me impressed. My apples are sauced. My cucumbers are pickled.